So the new chapter is function. Okay, now this is given in your lecture notes. Okay, so this is given in your lecture notes. I read to you the first note. Function. Function is a relationship between two sets of numbers whereby each element in the first set has one and only one corresponding element in the second set. Now, what does this mean? We are trying to define to you what is a function. So we look at here. So they say a function is a relationship between two sets. So we have one set of numbers here and another set of numbers here. We have two sets of numbers, okay? So what they say is that there are two sets of numbers. The first set has one and only one corresponding element in the second set. Now, what does that mean? It means that this is the first set of numbers. Each number in this set here, the first set here, they have an answer in the second set. For example, 1, after undergoing a certain function called f, the answer will be A. And there should only be one answer. If the one there has two answers on the right-hand side here, that means it is not a function. I'm going to explain further, right? Now, before I carry on, every number in the first set, every number, all the numbers that is in the first set here, they all have only one answer in the answer set, in this set. They only have one answer in this set. So let's say A, 1, answer is A. 2, the answer is B. 3, the answer is C. 4, the answer is D. And 5, the answer is E. You see that each number, 1, 2, 3, 4, 5, each of these numbers, they have only one answer. Okay? If that is the case, then it is called a function. So this mapping here is called a function. Now, before I carry on, I want to tell you that this set of numbers on my left-hand side here, the whole set of numbers is called the domain. This set of answers here, the set of answers here on the right-hand side is called the range. The mathematical calculation that map this 1 onto the number A is the function f, Okay, so let's say I have a number here, the question. Then I have the answer here after undergoing the calculation, which is called the function. I have an answer here called B. Okay, so all the numbers that is in the question, this whole set of number is called the domain. All the answers after undergoing the function f, this set of numbers is called the range. So far, are you familiar with the terms that we are using? You understand the terms or not? Okay. So basically, it means there are two sets. One set is the question. The set of numbers in the question is called the domain. Then another set is the answer. The set of numbers in the answer is called the range. Who is the one that bring one number from the left to another number to the right? that one is called the function. Function, sometimes they call it by the name f, sometimes they call it by the name g, sometimes they call it h. Okay, so that is the name of the function. F, G, or H is the name of the function. The question is the domain. The answer is the range. Okay, so you understand. Now, this type of function, whereby one question, one answer, one question, one answer, this type of function is called one-to-one. It is a one-to-one function. We call it one-to-one function. Okay. Now we look at the second type here. These are the numbers given in the question. 1, 2, 3, 4, 5, right? And for this number 1, I can have two answers, A and B. Now, this type is not called a function. This is just a relation. Just a relation. One question, you can have two answers. Ever come across this type of question? Let's say, for example, square root of 2, square root of 4. Square root of 4 can be plus 2, it can be minus 2. So there are two answers. Which one is the correct answer, or both is the correct answer? Right? Okay, both are the correct answers. But this type of relation, whereby you have one number in the question, two numbers in the answer, is not a function. It is not a function. No, it is not a function. Worse, there are some numbers not used up here. Definitely, this is not a function. So we look at another type of relation, or another type of relationship. You see this number 1 here. Of course, this is called one-to-many. This is called one-to-one. This is called one-to-many. One-to-many. So this type of relation, one-to-many, is not a function. This type of relation, one-to-one, it is a function. Now we look at this type of question. Many-to-one. Many-to-one. So you see, 1, the answer is A, only one answer. 2, the answer is B, only one answer. 3, the answer is also B, only one answer, right? But two questions, they share the same answer. It doesn't matter. As long as for one particular number, there's only one answer. For example, 2 here, answer is only B. It is not A and B, it's only B. Then the number 3 here, only one answer is B. So this type is called many-to-one. Many-to-one. Now this is still a function. Why is this relation one-to-many called a function? Because one question, one answer. It doesn't matter they are sharing the same answer with other question or not. Okay, so far, any question?
No.
No question. So you see the first one, right? This one is a function. The third one is a function, but the second one here is not a function. Now, why? Well, we look again at the definition. First set has one and only one corresponding element in the second set. One element in the domain correspond with only one element in the range. That type is called a function. So far, we found out that this is a function, one-to-one is a function. Many-to-one is also a function. One-to-many, not a function, because one question got two answers. Then you look at this one. This type of relation is called many-to-many. This one answer, one question, two answers. Sometimes two questions sharing the same answer. So this type of relation is called many to many. Then I ask you, hey, this relation many to many, is it a function? Can you answer me? This one, is it a function?
If one to one function, many to one function.
Now, in order to decide whether this is a function or not, you check and see. One element correspond to one element. Got or not? One element correspond to one?
No.
Huh?
No.
No. Then is this a function or not?
No.
No. So you see, if it is one to one, then it's a function. So this type, one to many, many to many, they are not a function. They are not a function. So you know what is a function and what is not. Now, this function here actually is a mathematical calculation. In your case, it's a mathematical calculation, right? They give you x plus x squared, x minus 1, 2x plus 5, like that. It's a mathematical calculation, this function. Okay, so now we look at this is a function that bring one element from the left-hand side to one element on the right-hand side. So this is called f. Sometimes we can have inverse function. Inverse function means it is a mathematical calculation that bring one number from the right to one number from the left. In other words, this inverse function is a formula, is a mathematical calculation, is a formula that will bring this same number on the right back to the same number on the left. So if there is such a calculation, or if there's such a formula, then that formula is called the inverse function. So if bring this one over here, then this one bring it back, this one is called the inverse function. However, this inverse is a function. This inverse is not a function. Why? Because you see here, one element, it doesn't correspond with one element back there. One element correspond with two elements here. So the inverse is not a function. This one, the inverse is a function. Any question?
No.
No, you understand, huh? Why this inverse is a function? This inverse is not a function. Okay. Of course, this one, no need to look at this. Many to many, one to many, no need to look at this one. Because going is not a function, then we don't bother whether coming back is a function or we don't bother. This one, going is not a function, so we don't bother whether they come back is a function or not. We don't bother. So in other words, we actually, most of the time, we actually encounter one-to-one function, many-to-one function. Most of the time we encounter this. And one-to-one, the inverse is a function. One-to-many, the inverse is not a function. Okay. Second one, vertical line test. An equation specifies a function if each vertical line in the coordinate system passes through at most one point on the graph of the equation. Oh, what does this mean? What does this mean? Okay, now what they are saying is that this function probably can be represented by an equation. Okay, let me underline this. This function can be represented by an equation. Equation specifies a function. Let's say, for example, this line here, okay, never mind. An equation specifies a function. It means that this function can be represented by an equation. Now, once it is represented by an equation, I can plot the points and draw the graph of this equation on a graph paper like this. Okay? So sometimes I may get this shape. Sometimes I may get this shape. Sometimes the equation is represented by this shape. So in other words, okay, in other words, it's like this. Function is represented by an equation. Function is represented by an equation. After I'll show you the example. Now I want to explain what they are talking about. A function can be represented by an equation. This equation can be represented by a graph. This equation can be represented by a graph. So instead of looking at the equation to understand the function, we try to look at the graph of the equation to represent the function. Okay, never mind. So let us look at this type. Now this type of graph, a circle, actually it can be represented by an equation. You know how the equation looks like. Let's say the center of the circle is 10, 11, 12. 12 and 7. 12 and 7. X minus 12. X minus 12 square. X minus 12 square. Plus y minus 7. Y minus 7. Y minus 7 square equals to 1, 2, 3, 4, 5. Okay, let's say equals to 5.5. Okay. So probably this graph here, which is a circle, can be represented by an equation like this. Okay. So now I look at this equation as a function. I look at this equation as a relationship between two variables. The two variables, they are x and y. They are x and y. Now the x here represents the domain. The y here represents the range. One more time, look at it. So, okay, I clear away this first, then I explain. Okay, so we see we have two numbers, one set of number here and another set of number here. This set of numbers here, if we plot them on a graph paper, this set of numbers is represented by x. This set of numbers here, the range, is actually represented by y. In graphical form, if I plot the function in the graph form, then these numbers here, they are actually x. These numbers here, they are actually y. So coming back to this here. So when I see a circle like this circle, which is a graph, actually is represented by an equation, something like this. And this equation is actually, whether it's a function or not, we don't know, right? So what the textbook or your lecture notes ask you is that, hey, if the graph is this line, does it represent a function? If the graph is this line, does it represent a function? If the graph is this line, does it represent a function? Then you may ask, hey, how to know just by looking at the graph like that, I know whether it's a function or not a function. I'm going to explain to you. By looking at the graph, you will know whether this equation is a function or not. How? Okay, you listen. Now, look at this. I pick one value along the x-axis. I pick one value along the x-axis. Let's say I pick this value here, 5, 6, 7. I pick this value 7. Then I shoot up parallel to the y-axis. Pick up, shoot parallel. I see that this line, x equals to 7. This is actually 7. 5, 6, 7. So this 7 here, x equal to 7, cuts the equation, cuts the graph, cuts the function of the graph. The graph of the function, sorry. Cuts the graph of the function at 2 points, at 2 points here. So this point will give rise to one value of y, which is 4 point something. This point give rise to another value of y, which is 10. So that means when x is equal to 7, y equal to 4, and y equal to 10. Got two answers. So now you tell me, does this represent a function? This equation here, does it represent a function?
No.
No, no, you are right. Very good, you are right. Because this is the domain, this is the domain. The x-axis here, the numbers along the x-axis here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until infinity. These numbers here represents the domain, And if it is a function, then one number from the domain will only correspond to one number in the range. Can you see the word range here? These numbers here are all the range. So that means one value of x should give rise to one value of y. Then it will be a function.